Hello everybody, my name is Sergey and I will be a moderator for today's session. It's very nice to meet you guys and I hope that you will have a really great experience. So I would like to note you that today's session will be recorded and you will be able to look the recording after it ends. You'll also be able to get materials and you would also have a great ability to answer questions to ask questions, sorry, that our great presenters will be able to answer later on. So don't be shy, put your questions in the chat and we will answer them just as soon as presentation will be come to an end. So I would like to present our first speaker for today. His name is Andrei. Andrei was working as a team lead on a project that he will be presenting, and he started the test automation solution with the goal to have efficient and effective testing process. Then the project was passed to Dmitry, who was playing a team lead on the project after Andrei. So guys, I'm passing my word to you, and I wish you a really great session.
Thank you so much, Sergey. So let's start with my presentation. My name is Andrei, and please let me know if you can see the screen. Hopefully you can.
Yes, we can.
Okay, that's great. So today we will speak together with Dmitry. First part is mine, and I will tell you about our experience of creating test automation framework. I was a team lead at this project, and Dima continued my work after 2 years of my team leading. He is a team lead there now. And I will tell about how we created something that was working and that is working. It will be not about something unique or maybe technical, some super interesting thing, but it is a set of best practices we collected together, and we met our expectation, needs, and our goals, what we would like to achieve. So first of all, we started the project with literally nothing. So we had a 0 test cases, we had 0 coverage with automation, we had a big project, legacy project with, in future we estimated the regression about 1,000 of test cases. And we started with no API, it was almost whole UI set. And we had a vicious circle, we had a very, a lot of manual effort to test new features because product was really fast developed. With this, we didn't have time to automate our testing, and we didn't have automated testing to reduce our manual effort. In these conditions, in these limitations, we started thinking about what we really need, and we needed a framework that would allow us to create test cases really fast, because it's important. About 1,000 test cases, maybe 2 years to automate, it's not our case. We needed to set up regression in maybe half year to start working effectively. With this, we needed to run test cases fast, and our goal we set was about 30 minutes for regression suite and 5 minutes for our smoke tests. And with this, we needed to maintain our test cases and test runs and make analysis really fast and make maintenance cheap. So thinking of this, we created, and one more thing about our application. It was a SharePoint-based application, and maybe you're aware of how WebParse model works. Who doesn't, I will tell. Our application is about journals, a lot of journals or magazines with a lot of pages. I would say 70% of them were really typical, with typical pages, but about 30% were unique. And it's kind of a set of pages that is shared maybe among several journals only with different combination of web parts. Web part is a UI piece of information, like some block with its logic, and each page consists of several web parts. And set of web part can be really different. It's how to set up. So we started thinking how to automate, taking this into consideration. And one more thing, customer asked us to have a structured test cases. They call it test bed, and we started calling it test bed as well. So test bed is a structured representation of our test cases divided by application areas. So first three terms are pretty similar: area, region, section. That's what customer wanted. A bit explanation. So area, region, it's rather about business area in the application, and section, we decided it will be like a web part. And feature is a feature in our application, so what can we do, some action. And test case is a action with some parameters or conditions, because the same test cases can be applied several times with different conditions. And yes, my talk is about .NET world, it's not Java. And a screenshot from Visual Studio, how we divided this test bed, how we projected to code items. I will explain a bit more in future. So at this point, what's important, a customer really wanted to have our test cases structured in this way. And we had several teams in the project, and some teams were really frustrated how we should do it, because we don't understand these terms and why we really need it. Our team decided not to be frustrated, but try to use it with some useful way for our automation. And what we decided to drive our test automation framework structure by this test cases structure. So as our team consisted of 5 people, and all of us were mixed test automation and manual engineers, so everyone could automate and could do manual work, we created test cases, we automated them. That was an interesting setup. With this, we decided to make it really useful for our work as well. And when we created test cases, we know when in our test bed, in our structure, it should be placed, and how we can create the appropriate structure in our test automation framework in Visual Studio. And it really helped us in future, but it will be next slides. So combining all this context, all these starting parameters, I would say, we decided to have test automation framework in the following fashion. So first of all, we decided to have tests short and readable, like in BDD style, but it was not BDD. We reject using BDD. With this, like behavior driven or domain driven, I would call it, meant that automated test cases scripts should be readable and understandable for not only engineers, not only for our team, but for business people as well. And they should be short, they should be atomic. So for example, if we need to log in some test case, we don't check that login works correctly in this test case, because for this we have another separate atomic test case just for login. And in each test case that uses some another logic, we assume that logic is working correctly. So this was the first rule. The second rule is about like technical stuff. We decided to use NUnit just because customer insisted to use MS test, but we decided it would be not helpful for us just because of parallelization and data-driven testing, and NUnit is much more appropriate for this. And we decided to use models business value objects everywhere it can be used. So we don't use like some primitives like strings or integers in our tests, in our methods. We passing everywhere the whole object. If it's about user, we create user, maybe with less information, maybe with more information, and pass to the method it's needed. Or it can be journal or journal issue or article. only business object, just to make code understandable for everyone. Because we didn't have business analysts in the project, and QA folks worked as BAs as well. So we were in collaboration with our product owner, and we created requirements, we analyzed requirements. So for us, thinking in business terms were much more easier than in some primitive types. API. We didn't have API in pure way, so we just did have SharePoint API that's provided by Microsoft, and I would say that's it. This was one another challenge we had, just because about test data, how we could use, how can we understand that something is we need to use in test case, as we don't have API to get relevant data. We didn't have access to database to get relevant data. So the only thing we had was UI. And we put our test data in static classes. I will share some example later. So combining all of this, we created a test automation framework in about 1 month. It was about core in our framework. It was about 1 month, and we still didn't have enough time to start automating, because we had a lot of manual effort, as I said, and we talked to customer, and customer said, okay, as you created a framework that you assure us it's really fast to create tests, you have 2 months, you have 2 people, please create your automation. So it's about 40 days and 2 people. How many test cases we could create? Average speed from my experience, it's about 1 test case per day. So about 80 test cases. It's almost nothing in our regression from 1,000 test cases, I would say. With this, we estimated our speed about 2 test cases per day, and it's much better, but it's not enough. So let's start. Let's go to another topic. We created an algorithm how we can speed up our test case creation, because it was the first part, just create test cases to have something to maintain, to have something to run. And using this algorithm, we speeded up test case creation to 3 or 4 sometimes test cases per day. And in 2 months, we automated more than 2,000 test cases, 200 test cases, sorry. It's about 240 maybe. Let's go through example. So our assumption, we have a test cases in TFS, our test management system. We created a manual steps. So we should log in. It's about buying article access functionality. Simple example. And we open article, we click buy, we enter some card details, we confirm the purchase, and we verify we really got access. So we created test case. So what's the next? The next, we create structure in our test automation framework. As I previously said, it's driven by our test cases structure, by our test bed. So you can see some folder like a e-commerce, it's a region, and PPV, it's our region area, and the test case, web part. And web part, purchase control wrapper web part, so doesn't matter the name. It's just about this web part, and in another journals, in other pages, the web part will be the same. We really know it. It's guaranteed. And the functionality, it's a class that's called by the name of test case. And we create at this moment appropriate steps that is used by test case. And steps, it's a web part steps, and we create web part like a UI object. After structure is created, we create method names. It's like a definitions only. So by article, it's a test case name in our class, and 3 methods in steps that are involved into the process. So we enter card details, we confirm purchase, we verify access. These steps are related to this web part, so they put here. About previous steps like open issue or login or open article, they are in another web parts, they are in another classes, they are in another methods. And UI object. So we created a decorator on web element, and we created it just a property style. So we identified which UI objects, which buttons, which drop downs, etc. we need, and created their definition as well. So then we fill these definitions with logic. So first of all, we created test step. They were not implemented, they were in red, but that's okay. And you can see our test is really understandable. For you who are not involved in the project, you can't understand what's happening in the test because it's pretty well described, self-described. Also, business people could understand this. Then we implemented UI object, so we put some XPaths into our titles, buttons, labels, etc. And then we implemented steps logic, so we put actions with our UI objects into the step. It's pretty easy algorithm, but it's working because it's defined, and you should just go through the steps, and after 10th test case, you will do it automatically, and it's pretty easy to create. And after this, the test will work. The only thing we need to finish is some categorization for running test cases, for putting test cases ID, etc. And you can include it into its category critical, so our critical path test cases. Easy. What is and my speech is named domain-driven style. Where this domain-driven style, you ask? Exactly what I described. It's about our understanding of domain-driven style. And first of all, it's a driven. That test automation framework is driven by our test bed, by our logic, application logic, business logic. The second thing, tests are written in domain-specific terms. So everyone can understand that what is paid article, what is order page, what is confirmed purchase in this case, what is current issue. So issue is not a problem, issue is a set of articles in journal. Business people understand, and business object everywhere. You could see this as well. We operate with business objects like journals, articles, etc. The only maybe exception in test case, we use data-driven style for n unit, and we can use some strings there. But that's it. So, like a conclusion, what we really got, what benefits? We reduced our manual effort. At this point, it was about 70%, not 30, not 50, just 70% of manual effort. But for us, it was really great achievement because from 0 to 30 in automation effort, that's really great. With this initial, we called it blitz work, 2 people, 2 months, we automated most important test cases, and we saved our time to start automation work for future. And we create, as I said previously, in 2 months, more than 200 test cases. Our regression were about 10 minutes. What's not about 30 minutes, but 30 minutes was put for our all suit from 1,000 or maybe 500 test cases. Dimo will tell more about how they will improve this and how it takes now. Maintain ship. Our data analysis took about 15 to 30 minutes if something failed, if some test cases were read. Why? Just because test cases were written in understandable way, it was pretty easy to debug, it was pretty easy to investigate what's happening. And also we implemented some technical stuff like logging, logging to report portal, logging to our internal files. The same about atomic test cases. If something happened in some step, we understand that it was in this step. Just need to, and this step belongs to another web part. For example, just run test cases for this web part. Running, if it passed, we need to debug this test case. If it's failed, the problem is another logic. For example, login. if issues with login, every test case almost will be affected, but we need to check just test for login, and that's it. And that's it from my side. So I pass the word to Dima. So please continue, tell how you made from our something really beautiful child. Everything to you. Thank you, guys.
Thank you, Andrei. And while Dima is preparing, I would like to give big thanks to you. It was really great. And Dmitry, go when you're ready.
Yes, I'm ready. Hi, everyone. Please let me know if you can see my desktop. I hope you can.
Yes, we can.
Thank you. So at this point, I'm going to talk about some technical challenges we ran into throughout meeting our main goals. And since not only did we get dependent on some processes things like strategy and so on, we also got dependent on technical things which our platform was built on. Since we got our customer involved in the test automation process, as more our customer got interested in test automation, there were more questions arisen throughout this process, like why our test automation requires some maintenance, how can we make it better, and so on. At some point, we realized we reached kind of glass ceiling regarding our strategy things and stuff, and we decided to switch to and look into technical things we might get better at. Our platform was based on SharePoint platform, and this slide represents the main flow of SharePoint. Let me tell you how it works. So once an admin user puts any data to site contents here, then it gets to the content database. Then after some time, so this thing is timed appropriately, the cache is getting dumped, and only after that does the data appear on the live site. And how our test automation worked at first. We basically manually checked by using Selenium automated tool. We checked site contents. We grabbed some data, went to the live site, and performed our assertion. Since we were wanting to make our test automation flexible as much as possible, so we didn't hardcode any expected data. However, this approach turned out not very stable as it seemed to us, since we had to wait until page is loaded and so on and so forth. And we started to think, how could we get better here? At this point, we, as Andrei mentioned, we came up with the SharePoint API approach. So how it works? So technically, we're sending respective get call to the content database, getting expected data, and perform assertion with the data on the UI. However, this approach is pretty simple here. What if we want to put some data and check it on the live site? As you can see, here is a cache tool, which is getting cleared by timer, and it can take almost 1 hour until the data appears on the live site. At this point, we came up with the specific tool, which we called from our test automation solution, and we had our cache dumped just rapidly. So it worked the following way. We put some data by using API call onto the content database. We triggered our specific tool. The cache was getting cleared, and we checked the live site on that. This approach turned out extremely useful and also stable. At some point, we realized that we had the test automation pyramid, which is represents at the left part, doesn't look like a pyramid at all, but rather some glass of wine, since we had lots of UI tests. We had no integration test at all, and we had a little of unit tests. And we understood there were things we could control and we could influence on. So we knew we could get better at UI automated tests and API. However, we got some UI automated tests, and we knew we met our initial goal, which was 30 minutes for time test automation window regarding smoke. However, it wasn't that enough for us. We had to wait 30 minutes until we understood if the deployment and the build is right or not. And not only did we want to get to the desired test automation pyramid, since it was according to best practices and so on, we also knew it would help us a lot in terms of production, build, health check, and so on. And we started thinking how we could make it happen. At this point, we decided to get focused on API testing here. We knew there was supposed to be something, some APIs which could be covered with automated scripts. We cooperated with the developers. We all together looked into developers' code. So the application was kind of inherited. We knew it was pretty huge. No one knew it at all, not at all, just thorough enough. So we spent some time investigating, and finally we found some integration services. Throughout our investigation, we understood that there were some API endpoints and some API calls which didn't have any impact on the current application at the first look. However, we decided to cover all these APIs with respective manual tests, and we put it in test bed according to rules Andrew mentioned before. And after that, we covered these tests with automated scripts and added them to the CI pipeline. It has to be said that those APIs, which were kind of unuseful at the first look, they turned out very useful and conclusive, I'd say. Since, as I mentioned, no one knew the whole picture of the application, and unused API at the first look turned out dependent on some relevant UI things. So these APIs failed, and we also figured that some important UI features were broken as well. So at this point, this creation of API layer helped us improve our test automation window metric a lot. So currently it takes less than 7 minutes to understand whether a build is good or not, whether deployment was done correctly or not. But also we included those API checks into our test, our quality gates. So if API tests fail, we don't deploy our build to the further and upper environments. Next thing we were focused on was login. This slide represents basic SharePoint login flow. As you can see, it's pretty complicated. And we used firstly UI1. However, it as we all know, it's unstable. We ran into some click interception errors, some timeout exceptions, and so on, and it wasn't useful for us. Also, as our tests were atomic, we had a chance to separate login verification out of our logic. So, and also UI login turned out pretty slow. It wasn't enough for us. And we started to think about API login here. And it's according to the best practices in test automation right now. And we encountered the following problem. So as you can see, there are too many redirects here in SharePoint flow until the user gets logged in. And we spent some time investigating this flow. We eventually covered everything. These things are pretty tight according to the timeline. And eventually we were able to repeat all these redirects and get our test automation user logged in. However, this approach turned out pretty unstable due to the timelines. And we were about to give up. However, we decided to try to make one attempt and to try programmatic login. How it works. So at some point, we found out that this accession control service gets us some token, and if its token gets appended to the current URL, all this flow is not going to be interrupted. So that basically means we can take this part of application and put some data here, some login and password, get this accession token, put it into the URL, and the user will get logged in. So we worked with developers. Again, we created specific delay library and added to our test automation solution. And currently it works in the following way. We just call this library from our solution. We get this URL, we get this token appended to the specific URL, and we are getting logged in. So this approach is way more stable compared to previous ones. But also this approach helped us to save 5 seconds at every single login. So the next slide represents one of our specific project-specific tool called Data Loader, and I'm going to tell you how it works. So basically, we have 2 isolated servers, and there is no way to get to the servers due to some security level and so on. So the good thing is these servers are communicating with each other. At one server, we've got 2 Data Loader instances. One of it is production one. So it's in listening mode, and it gets some messages, processes it, and load respective data to the content databases and to the UI itself. And the second one is a local version of the same thing. You can put some command here, and the process will be the same. And we started to think how we can automate this, since it looked as a thing which can be automated, and it must have been automated to us. Also, this is it's extremely vital application, extremely vital part. There is no way we can certify our release without verification of this part. So first attempt wasn't that positive as we think right now. We tried to put some version of test automation solution to the server itself and use this local instance. We were putting some comments here and checking what happens in the database. However, as you can see, this logic covers only a little piece of all the flow, and it wasn't good enough for us. And also, we had very unstable solution again, so we didn't meet our goal. So we had to go to the server to check to run the data, then to check the results and so on. It wasn't convenient at all to us. And finally, we decided to try a new approach. So currently, automation framework sends respective messages emulating this real system and verifies using API, SharePoint API, verifies the UI and also partially database. By using this approach, we have not only the test stable, but we have also business flow covered, fully covered, I say. And one more thing we have struggled with was message processor. This application is pretty vital for the releases as well, and it works in pretty much similar way. Let me tell you how. So once a user makes respective actions on the UI, some data gets to the database, and it picks up by a listener of message processor, which communicates with SMTP servers, sending messages to a user. And there was too complicated to cover everything here. And here we decided to apply breakdown structure. So first of all, we decided eventually to get connected to the database. I mean, at this point, we showed to the customer that the only way we could cover everything if we had database connection, and we got it finally. So at this point, we put some data from test automation solution itself. We put some data to the content databases, emulating the real application. These data were picked up by message processor, and we verified our mails by using some specific tools like 10 minutes email. So, however, as you can see, this flow covers not everything, and we decided to cover the rest part as well. So at this point, we applied here additional verification. Here, our UI automated framework emulated the real user behavior, clicking some buttons and links, and we, by using the same database connection, checked the database changes. This approach turned out stable as well, and all the business flows were covered. So at this point, to crown it all, I'd like to say that even though we are dependent on some technical and some process things, even though they're somehow running into some issues, there's every time the way to make our test automation solutions more intelligent, more reliable, and stable. That's pretty it from my side. Thank you.
Thank you, Dmitry. Take a deep breath. It was a great presentation. I would like to give you many thanks for sharing your expertise. And we already have a few questions in the chat. Just a quick reminder to the audience, don't be shy. If you have some questions, put them into the chat and I will pass them to our speakers. So, Dmitry, the first question will be tightly related to the topic of your presentation. So, what is the difference between business-driven testing and domain-driven testing?
Let me answer this question. So it was some research about terms, what is domain-driven and what is behavior-driven or business-driven. I would say it's almost about the same. In our case, we decided that using domain-driven is more appropriate because it can be business-driven in our say.
Okay.
So yeah, answer your question that there is no difference in our case.
Yeah, makes sense. So the next question will be regarding why didn't you prefer this approach instead of using SpecFlow for C# test automation framework? Who would like to answer that?
I can continue answering. It's pretty easy. Just because we did not expect that business users will be involved into our process. We didn't expect that any pure manual testers will be involved, and we did not expect business analysts in our project. We started not using BDD because it's one another layer of abstraction. It's our complexity.
So basically what you're saying that in your case, you didn't have any benefits of using BDD and decided to make your life easier, right?
Exactly. With this, you saw the code. It's a BDD style. So Dima maybe can answer why they did not decide use BDD in future. But when we set up the project, the framework, it was this decision.
Okay.
Yeah, thank you. So I can proceed with that. We didn't switch to BDD, to my mind, since we didn't have all the process based on BDD. So our stories aren't written on BDD. So, and also we have this level of trust. Then we are running, our team is running test automation itself. So there is no business involvement in test automation according to technical things. However, this approach turned out pretty easy and simplified a lot our life for knowledge transfer and so on. So the test cases, they are readable. So yeah, that's pretty much it.
Great, thank you guys both. And just as we were speaking, one more question emerged. Give me a second to read it and I will pass it to you. Okay, so the question sounds like this. Do I understand correctly? You use API testing as functional testing and not as end-to-end testing. So I'm not sure that even I get the question like totally, because basically it's kind of
Me
saying
too, but
about,
Dima will answer.
yeah.
Thank you, guys. So I can throw a bit light on our usage of API. Our API is basically used in two ways right now. So the first way, they are using as a separate layer. So they're kind of end-to-end verification. So starting from the gathering the expected data, for instance, from the database, then getting data from the API itself and sorting everything. Also, we use those APIs to get expected data in case we don't have access to the database on some environments, for instance, on the production. Also, there are three days. Okay, so also these APIs can be used as helpers. So we can call some API to get some additional information as a go-between. I hope I answered the question.
Yeah, I really hope as well. And just as you're talking, a few thank you notes arise. So thank you guys for sharing your expertise. Right now we don't have any unanswered questions, but just if you think that you still have something that you would like to clarify, put your questions to the chat while we slowly will wrap up this session. I would like to kindly remind you that you leave your vote. I also already posted a link in the chat, so you can click a link and click a vote on the session. You could also rate other sessions that you attended as well. Thank you not only to our presenters, but to our great audience as well. It was really nice to talk both to you and with you guys. So have a nice day, everybody. Have a productive day. Yeah.
Sergey,
Yeah.
while we have a minute, let me speak a bit about one more thing. So, as I mentioned, this is not about something really technical, unique. This is something that's working. With this, I'm involved into the interview staffing process, and I had a conversation with a lot of people about their experience, their frameworks, their approaches, and what I see really, this approach is not so popular as I would expect, and I strongly believe that it can help to maybe not everyone, but a lot of people. So if you have any questions, or maybe if you would like to try it, or you don't understand benefits or anything else, don't hesitate. Ask us. We will share our experience, our expertise, and I believe it will make your life easier. And now that's it. Thank you so much again.
Thank you one more time. Have a nice day, everybody. Bye-bye.